Hello people, I am Michael James Ambrosio of BSECE 3A, and today we're going to talk about impedance matching. So first, what is impedance matching? So it is matching source and load for it to deliver maximum power transfer. It required matching networks to be used to minimize signal reflection from the load. Also, matching networks composed with the reactive components only so that no loss added to the overall network. So we have here the matching techniques, and we have four different types. The first one is the quarter wave transformer, which is for purely resistive lossless lines. The lump element networks, which has three parts: the L network, pi network, and the T network. The stub machine, which has four types, and the double shunt, which has four types. So today we're going to focus to the L network. So okay, the L network is a simple inductor capacitor circuit that can be used to match a wide range of impedances in RF circuits. There are 8 different mathematical combinations, but only 4 are considered valid. So these are the 4 combinations of L network that considered valid. So next, the L network is the most common lump circuit that have 2 cases. So this is the 2 cases for the L network. So the JB is connected in parallel and the JX is connected in series. So in getting the capacitor in the L network, we have first to get the B and the X. So we have here the formula. So positive X equals inductor, negative X equals capacitor, positive B equals capacitor, negative B equals inductor. So for case 1, when RL is not equal to 0, we have here the formula for B. And also, we have here the formula for X. So possible answer could be B1 and X1, B2 and X2. So in case 1, this is the block diagram for case 1. For case 2, when RL is less than 0, we have here the formula for B, and we also have here the formula for X. So the possible answers could be B1 and X1, B2 and X2. This is the block diagram for case 2. So here we have here the problem. So we have here a sample problem. So design all possible matching L networks to match 100 ohms line load impedance of ZL equals 80 plus J30 ohms at 100 megahertz. So given ZO equals 100 ohms, ZL is 80 plus J30 ohms. So recall that ZL equals RL plus JXL. So the value of RL is 80 and the value of XL is 30. So this is case 2, since ZO is greater than RL. So now let's find B1. We have here the formula for B1, plus or minus 1 over ZO times the square root of ZO minus RL over RL. And this is its block diagram. For X plus minus the square root of RL times ZO minus RL minus XL. So let's input the given. So plus
5 times 10 raised to negative 3. And for x1, we have here the formula plus RL 80, 100 minus 80 minus 30. So x1 is 80, 100 minus 80 minus 30, 10. So 10. So when positive B, we have here a capacitor, and this one will be our inductor. Let's get the capacitor, which is the formula is B1 over 2 pi frequency of 100 megahertz. So B1 is 5 times 10 raised to negative 3 times 2 pi times 100 megahertz equals our capacitor is 7.96 picofarad. So for the inductor, we have x1 over 2 pi times 100 megahertz. So our x1 is 10, 2 pi times 100 megahertz equals 15.92 nano Henry. So our diagram for case 2 is this one. So our B will be capacitor, and our X will be inductor. So this is 15.92 nano Henry. This is 0.96 picofarad. So another is the negative. So B2 equals negative 10 over equals 80 minus 80. So B2 will be negative 15 times 10 is to negative 3. So now this is inductor. So our formula for inductor is negative 1 over 2 pi 100 megahertz times B2. So 3.31 nano Henry. And for x2, we have a negative square root of 80, 100 minus 80 over 30. So our x2 will be negative 70. So this will be our capacitor. So no, we have the same formula, 2 pi times frequency of 100 megahertz times x2. This will be 22.74 picofarad. The diagram will be the B will be the inductor, and the capacitor, and the X will be our capacitor. Now we have the final answer. But we are looking for all possible matching L networks. So we also need to consider the case 1, since we also satisfy its condition, which is RL is not equal to 0. I have here the formula and the block diagram. So for B, so for B1, 30, 30, plus square root of RL, 80 minus ZO, I divided by ZO, RL is 80 squared plus XL. XL is 30 squared minus 100 times RL is 80. It is divided by RL squared plus XL squared. So math error. So this is infinity. So let's try the negative, the B2. B over 100, so 80 squared plus squared minus 100 over 8 times 80 divided by 80 squared plus 30 squared. So we're just going to change the positive here. So we also get an math error. So B2 is also infinity. So we have only two possible solutions. This one and this one.
So lastly, the sample problem. Design a valid matching L networks to match a 100 L line, 100 ohm line to a load impedance of ZL equals 75 minus J50 ohms at 500 millihertz. Megahertz. So we have here the solution. So you can practice the sample problem at your home. So you'll be able to know deeper the L networks. So that's all. Thank you.